Alright, what's up? It's been a while. I think I didn't stream until, well, since last Sunday. As you can tell, some things have been upgraded. I got a new mic, so hopefully the sound quality is better. And you can see I kind of left a transparent background for chat, and then just a reminder for people that just tune in that you can at me in chat for math help. Oh, and then I have 2 unbanned requests. So I kind of wanted to go through this with you guys because it seems kind of funny. I'm back. So let's see. Where are my unbanned requests? Two people that decided to use real names. Why? With the message, why did you ban me? Deny. Add a note. Too bad. Send this decision to them. See you later. I'll actually never see you again. Another person. This is an unreasonable ban. I'm gonna deny this person as well. You're unreasonable. Send. See you later. Well, actually, see you never, just like the first person. Okay. And then this person that just subscribed or followed, I know why you can't chat. Because one of my mods put a follower timeout before you can chat in, well, the chat. So go into one of your older ones and maybe you can finally talk. Anyways, as you can tell from the title, today I'm going to go through HL Math, Analysis and Approaches, Standard Level, Paper 2. I hate Paper 2s, just because I hate using calculators. But whatever, we'll try it out, see if I can get PB. So let's see, here's number 1. Let me copy this. And I don't like this music. This music sucks. Hold on. I guess we're back to lo-fi. Always back to lo-fi. Alright, let's get to this. We have a metal sphere with a radius of 12.7 centimeters. Find the volume of the sphere. Make sure that your answer is in sort of scientific notation. See, this is why I hate calculator questions. Like, what is this? I just put this into a calculator. Alright, first off, what is the formula for the volume of a sphere? I hate memorizing stuff. Is there more? They don't even give you the volume of a sphere? I feel like this is a mistake with the formula booklet. I'm pretty sure I know what the volume of a sphere is, but I'm just gonna double check. Is it 4 over 3 r cubed times pi? Volume of a sphere. Yes, it is. Alright, so 4 over 3 r cubed and there's also a pi in here, and then you just put this into a calculator. It's like not even fun. So 4 divided by 3 times 12.7 times another 12.7 times a third 12.7 times pi. Where's my pi button? Here it is. Okay, 8,580. And then if you take a look at the formatting of the answer, they just want the first digit. So as long as I put this into the calculator properly, which no guarantees that I did, the answer is, well, 8 rounded up to 9 because it's 8,500, blah, blah, blah. So 9 times 10 to the power of 3. And we should probably give the units here. Okay, and then the sphere is melted down, and then we're going to change the shape into a cone with this height. Find the radius of the base of the cone, correct the two significant figures. Okay, so obviously the volume of the sphere, because we just remodel it, this just becomes the volume of the cone. So let's use our answer from part A. 9 times 10 to the power of 3 is equal to the volume of a cone, which is 1 over 3 times pi times r cubed, or r squared rather, times h. And then of course we know the height of the cone is 14.8. At least they're very nice to you guys, giving you such an easy question at the beginning. Oh, I should use the Texas Instruments one that I have right here. Where's my music? Okay. Let's see. We take this, and then we're going to times it by 3, divide by pi, divide by 14.8. So 9, and then where's the stupid button? Second, E3. So take this. Divide it by pi. Where is pi? I'm blind. I cannot find pi right now. Oh, there it is. Second, this thing, multiply by 3, divided by 14.8. And then here's your height. So what is that? 580.7. And then you have to be careful for math and IB. We have 3 significant figures, so the answer is 581 centimeters. Nice. At least I hope it's right. Okay, number 2. More geometry related things. I can't chat. Well then, I've told you this so many times. Stop making new accounts. Did you listen to what I said? You need to use one of your older accounts. Brand new accounts have a time limit before you can chat. Alright. So we have this circle, part of a circle, radius of 4 centimeters. We have this triangle. We have this angle. Then we need to find out the value of theta, and then you need to give your answer in radians. Okay, so one thing is you should probably add in a bit more information. You know that this is a radius, so this is also 4. And if you have 3 sides of a triangle, you can find any of the 3 angles using cosine law. So let's go to our formula book and find cosine law. specifically for angles. I think the formula book gives you two. This is HL. So right here, this second one. So if we want angle C, then we add A and B and we subtract C. So if I want this one, then these are my A's and my B's, and this one is little c. So we have cosine theta is 4 squared plus 4 squared minus 5 squared divided by 2 times A times B, so 2 times 4 times 4. And of course we get this answer, and then we'll need to do the arctan of cosine to figure out what that is. So clear. And then I'm just gonna do arctan right away. And let's see, we have 2 times 4 squared. We're gonna subtract 5 squared. I know I could just type 25, but oh well. Divided this by 2 times 4 times 4. So 2 times 4 times 4. Bracket, bracket. I think that's all the brackets I need. And then 1.35. And then again, always in 3 sig figs, and also be careful, you want your answers in radian, so make sure your calculator is in radian mode. I didn't check that, but I'm pretty sure it defaults to radian. Okay, and then we need to find the area of the shaded region. So, well, why don't we find the area of the circle and subtract the area of the sector. Each one of these is easy enough to calculate. We can just, with a radius of 4, and then now we know what theta is. So this is pi r squared, so pi r squared. And then this one, the area of a sector is another formula in your book. Somewhere in chapter 3, section 3. Area of sector, 1/2 r squared times theta. And then theta has to be radians, but that's fine. Everything was in radians already. 1/2 pi r squared times theta. Okay, all of this is calculator work. So let's put this in. Clear it out. 16, which is 4 squared, times pi, subtract 16 times another pi, times 1.35, that was the angle in part A, and then divide by 2. You're being so annoying. Can you even hear me? Okay, so here's your area, 16.3. And what is your measurement? Centimeters. So this is 16.3 centimeters squared. All right, second one. Okay, January 1st. Lori is going to invest P amount of dollars, and then it has an annual interest rate of 5.5. It's compounded quarterly. The amount of money in her account at the end of each year is a geometric sequence with a common ratio r. Find the value of r, give your answer to 4 significant figures. Okay, so this is a compound interest question. We can use a formula for compound interest. So go up to your topic 1, and then here it is. Future value is present value times 1 plus the annual insurance rate, interest rate, divided by 100 times the compounding periods times n for however many years you're investing this. So one thing to notice is they want you to find out the value of r, and they don't mean r as in the interest rate. They want the value of the common ratio r, but that's not a big deal if you look at the formula. Basically, future value is the next term in a sequence. So instead of writing FV, well, let me just write FV up top. This is UN plus 1. This is based on the present value, which is just your current money, UN. And then 1 plus the annual rate, which is 5.5. Divide by 100 times a quarterly compounding period. And then at the end of the year, we have the compounding period times 1. Wait, does it tell you how many years that she invests this for? Well, technically it doesn't matter. So, well then, oh here. This is the next year because it's n plus 1. So that means that 1 year has passed. So I'm going to multiply this by 4. So notice this is a geometric ratio where this term times this is the geometric ratio of r. Geometric sequence r, not the interest rate r. So this is what we need to find out. And then again, put this in a calculator. So 1 plus 5.5 divided by 100 times 4, and then big bracket to the power of 4. And let me just double check that this is right. It is not right. I need one more bracket. So 1.06. Okay, she does not make any more deposits or withdrawals. Find the year in which the amount of money Lori's account will become double the amount she invested. Okay. So essentially, we need 2 present values, 2 times the present value, to be equal to the present value and then Cupid Yoshi, thanks. We need to find out when this is doubled. And you do have the geometric sequence. I don't particularly care for it. What I'm gonna do is, I know that this is 4 times n, which is the number of years, of course. And I'm just gonna evaluate what this is. And then I'm gonna graph this, or use an equation solver. So let's see, 5.5 divided by 100, and then divide this by a 4, add this to 1, so 101375, 101375. Okay, the PVs will cancel out, so we're essentially just solving this equation for when it equals to 2. So we can just go to our calculator, and you can use an equation solver. I'm not a particular fan of using the equation solver. I'd rather just graph this function. 1.01375 to the power of 4 times x. And then I'm going to find out when this value is going to be 2. So I'm going to compare the graph of 2 with the graph of this. And I'm going to also change my window because I don't need to worry about negative values of x, nor do I need to worry about negative values of y. Because y is the interest rate, it's not negative. X is the amount of years, that's not negative. So graph. Okay, and then you can see my window doesn't fit. First off, it's too tall, so you can just go back and change this real quick. I'll change it to 3, because I'm only interested really in a y value of 2. And let's change this to 20 years instead. So here is where this equation will be 2. So what we can do is we can press second, and then we can calculate the intersection, number 5. And it's going to ask you for what are the 2 curves you're finding to intersect, because you could have more than 2 curves on the graph. So you select this one, it'll automatically go to the other one, you press enter, and they could intersect in multiple places, so you do need to tell it and move the cursor to around where the actual intersection that you're interested in is. So press enter, and then here, 12.6. Now, obviously, we want this to be in years. So, of course, it's going to take 13 years, because 12 isn't enough, you get it at 12.6. And then, of course, they want the actual year, and this is starting from 2020. So she will double her money into 2033 if we're all still alive by then. All right, next one. Okay, this looks a little bit more exciting. We have a 6-sided die, and it's biased. So for some reason, you can get a 6 a little bit more often than a normal dice. I think it's a little bit more often, 7 out of 10 times. The die is tossed 5 times. Find the probability of attaining at most 3 6s. So essentially, talking about who is this person? They're so annoying. We are flipping or tossing a dice, and we are counting how many 6s there are, and we have 5 attempts. So this is a binomial distribution. And I forgot the notation, but of course this means that your random variable is binomially distributed with, I think it's n times n comma p. So we have 5 trials, and the probability of each trial getting it is 7 out of 10. And then in part A, we want at most 3 6s. So you could have, 1 6. So you need to find the probability of this. You need to find the probability of 2 6s, 3 6s, and the one that a lot of students forget is there is the possibility of not having any 6s at all. So you do need to add the probability of getting no 6s. Now, of course, this is a little inefficient we do have a function for this. Binomial CDF, where the C stands for cumulative. So anytime you're adding up different kinds of results, we can use the CDF. You're hella annoying. Now go take a bath and then go away. So let's do that. I have too many things open. Close this one. Alright, quit. So in a text TI-84, we go to second, press vars for the distribution, and then we go down to binomial CDF. Alright, and then how many trials do we have? We have 5. The probability of a single trial is 7 out of 10. And then we are interested in an upper boundary of 3 sixes. So the x value is the upper boundary in a cumulative. Unfortunately, at least the TI-84, you can't do a lower boundary, but that's just a complement. Okay, so we do this. And let's paste. And then press enter. And then here's the probability. 0.472. Actually, let's write this formally. So the probability that you have at most 3 sixes is 0.472. Okay, and then here we need to find out if that third 6 happened on the 5th toss. Now this one's a little tricky because you do need to think about the context of that. If the third one is 6, then this implies that you got let me phrase this better. The third 6 on the 5th toss means that you got 2 sixes in 4 tosses. So again, that's what it means. Third 6 on the 5th toss basically is implying that you got 2 sixes on the 4th toss. So what we need to do is we need to find the probability that you got 2 sixes. And then we need to multiply this by the 5th toss, so another 7 over 10. So that was also another tricky part. Okay, so then this is in a calculator. So clear this, second distribute. And this one is a binomial PDF because we're just finding a single probability. So how many trials? We did this 4 times. Probability is 7 over 10. And I don't know if these brackets do anything, but it's a good habit. And I want 2 successful trials. Press enter. So this is 0.2646, and then I need to multiply this by 7 over 10. So times 7, divide by 10. So here is the probability that you get the third 6 on the 5th toss. So 185. Man, this is gonna be a short stream at this rate. fifth question. We have this table with x and y, and then let's perform a linear regression of the line x on y, and then equation 1 can be written this way, and then you need to find the value of a and b. Okay. This one, they're being intentionally rude to you because we are finding the regression of x on y, and traditionally we find the regression the other way around. But that's fine. Either way, you just have to be careful. And then clear this, and we need to put in a list. So second list, nope. Math. Uh-oh. I totally forgot how to enter in a list. As you guys can see, I think it's under distribution? No. Okay. Quick Google. Enter list in TI-84. For dummies, which is me. Stat and enter. Okay. So stat. I did press stat. How come I didn't see this before? Maybe I didn't notice. And then press edit, and then let's put in our list. We can put in x in list 1, it doesn't really matter. So it goes 15, 23, 25, 30, 34, 34, 40. Go to the next list. 20, 26, 27, 32, 35. So you see, this is why I don't like calculator questions or calculator exams. It's just a lot of punching in numbers. Okay, so we have our lists. Now keep in mind, list 1 is for your x's, list 2 is for your y's. And then what we do is we go back to statistics, and then we're going to calculate a linear regression, because that's what it's telling us to do. And then this is where the confusing part is. The x list, notice that in our equation, we want the x list to be the y values, which was list number 2. So we got to clear this out, clear this one out, and then list number 2, which is second number 2 right here. And then this one, clear it out. This is second, first one. And then we don't have a frequency list, so calculate this. Okay, so here's your A and B. 1, 2, 9, and then 10.4, negative 10.4. One point something, negative 10.4. Yeah. And then we have a regression of the line y on x. And then these are going to pass through the same point. And then you need to find the point. Okay, so one thing you do need to know is what a regression looks like. So if you were to plot this regression, it's, you know, generally some sort of increasing function like this. And then regardless of whichever regression you use, of course it's still the same regression. They need to go through the mean of each value. And regardless of whether or not you regress on one variable or the other, this is always going to be true. So if you regress this way, it's going to look kind of similar. It still has to go through the mean, and then of course the mean is just slightly reversed. But regardless, when they intersect, they will intersect at the value p and q, which is x bar, y bar. And if you're not convinced, what you can do is you can do a second regression with x and y, and then you'll have proper values for line number 1, line number 2. You can graph it, you can find the intersection, but either way, p is going to be this mean. Quirky scientist, thanks. P and y will be the averages of each list. So we can go back to stat, we can calculate, and then I think we're allowed to use 2 variable stats. So list 1, and then let's not confuse ourselves. X, I'm going to put with list 1. Calculate. Okay, so here's P, right? The average of my x's, 28.7. And then the averages of my y, which is further below, 30.1. Yeah. And then moving on, we're still in the short questions. I think this might be the last one. Typically IB asks like 1 to 9 around 6-mark questions, and then they ask you like 3 15 to 20 mark questions. So realistically, all of these questions you should be flying through. They should be straightforward. Maybe not the last one. I don't know if this is exactly the last one, but let's see. The displacement in centimeters of a particle follows this equation, and then we need to find the maximum distance. Okay, so easy enough to do. What we can do is we can go and graph this. Okay, so x squared times cosine of x, and then we're going to add 2x times sine x. See, like, what is the point of this? It's such a complicated function, and it only really is accessible if you have a graphing calculator. But anyways, okay, the domain is from 0 to 5. So just to be safe, I'm going to go a little bit before 0 and a little bit after 5. And I'm going to change my y values back to a standard -10 and 10. Okay, and then you can see it's not even enough to go to -10, but we can just change that pretty easily. Let's do 20. And we'll graph it. Okay, so here's the general shape of our graph. And you need to have a solid understanding of kinematics from physics. I need to make this more obvious. So S represents displacement. And this is very different than what they want to find out, which is the maximum distance. Displacement is a vector, and so And so it measures where you are in comparison to, say, the origin where you started. So anything that's positive means that you're to the right of where you started, and anything negative is to the left. So what I need to do is I need to compare, regardless of the sign, the largest value. So this is not going to be a maximum distance, even in comparison to over here. What I need to compare is the value at my boundary, which was at non-including 6. Wait, hold on, I can't see. At 5. So I need to see if this y value is absolutely larger than the absolute of this minimum here. And this is easily calculatable, because we can just find the minimum. And TID4, you need to choose the left boundary. Hello. And then you need to choose the right boundary, and you need to choose a guess. So I have a y value of negative 16.5. Which, if we had units, means that I'm like 16.5 meters to the left of where I started. And then I need to compare this with the value at 5. But oh wait, hold on. I think this is the value at 5. So that makes it even easier. Let me double check. You can, again, calculate values. You just need to tell it what x value you have. So I'm interested in 5. And it's right there. So a little misleading what I drew. But in case you did have a graph that was like what I first mentioned, now you know what to do. Slow day today. Okay, so clearly the maximum distance is, oh, this is in centimeters. So the max distance is 16.5 centimeters. Okay, and then we need to find the acceleration of the particle at the instant it first changes direction. So let's think about that. I need to find the acceleration, so I'm going to find the second derivative at some t value. I don't know, I'm going to call it t d, because that was when it changed directions. Now I need to find out what this value is so I can plug it into the second derivative. So where is that? When does it first change direction? So think about what that means. You start going to the left, and then you would change direction when you start going to the right. So TD, the time that I'm changing direction, the first time I'm changing direction is right here. So what we need to do is I need to find out this, which is a maximum. Again, that's a function on your calculator. So second calculate, and then I'm going to find the maximum. And let's go all the way over here to the left side of the maximum. Press enter, go to the right side. And then take a guess. So this x value, which is the t value, 1.52. So I need to plug in 1.52 into the second derivative. And there's a couple ways you can do this. You can, of course, try to take the second derivative and find the function itself. I believe your calculator can do this for you. Now, I know it can do for sure first derivative, but maybe not second derivative. So you see right here, we have dy dx. And then this won't let me do it. So outside of the graphing functions, you also have math functions. And in here, we also have a derivative function. And I have a feeling this is not gonna let us do it. And let me see if I can put in a second derivative in this function. Yeah, this probably won't work. So what we're gonna do is I'm gonna take the first derivative and then I'm gonna put that into the derivative evaluation function. And if there is a way to do second derivative in your calculator, then maybe you should remember that. But you've heard it enough from me. I don't like memorizing calculator functions. That's not fun. So let's take the derivative of the first term. So derivative of the first factor, we're gonna add, well, we're gonna subtract because the derivative of the second factor cosine's minus sine. And then likewise, we take another product rule of the second term. Oh, you guys can't see this, but there's a cursor for where my mouse is. So I often point to things and then I assume that you guys can't see it. So sorry, I'm taking product rule of the first term, that's these two, and I'm taking product rule of the second term, which is going to be down here. So sine t, and then 2t cosine t. Alright, so I can put the derivative function of the graphing calculator in here, assuming this is right. And it might not be, but the process is correct. So you do need to say what variable. Of course, we are going to derive with respect to x. This is the function. I'm taking the derivative of this function, so that would be the second derivative. So 2x cosine x minus x squared times sine of x plus 2 sine of x plus 2 times x times cosine x. And we want to evaluate this function for 1.52. And if I put everything in, I have this. So here we go. That's my acceleration. Negative 8.92. Centimeters per seconds squared. And I think that's it. Is that the last of the short questions? Then we gotta go to, yeah, the big boy ones. I can't even copy this completely without zooming out. Alright, let's see. Adam goes for a walk. His camp is at point A. He walks at an average speed of 4.2 kilometers per hour for 45 minutes on a bearing of 35 degrees. And then he stops at this point B. And then he goes on another bearing and changes direction and then goes for a hike for this amount of distance until he reaches point C. And then I need to show that angle ABC is 101. Okay. So let's add in the information that we do know. And I'm going to draw a larger picture over here. It's not that much larger, but it's fine. So this is his second bearing. And then here is his first bearing. And of course, because these are both pointing north, we know that these lines are parallel. And then this is A, this is B. I don't know really where to put this. I'm gonna put it right here and C. And we need to find out what this angle is, or we need to show that's 101, basically. And we'll add in the distances when we need them. Okay, so this is a little bit of geometry knowledge from pre-existing geometry knowledge. We have two parallel lines. They have this transversal from A to B. So these two angles right here, 35 and this angle here, uh, 35 and this angle need to add up to 180. They're supplementary. So if I take 180 and I subtract 35, I should get it. And then that's a 45? And now that we know what these two angles are, we can easily find out what angle ABC is, because angles around a point should be 360 degrees. So let me just write down the work. (360) minus 145 minus 114, and that should be 101. But we can always just double check with a calculator. See? So now I know this is 101. And then I need to find the distance from the camp to point C. So now I need to find this one. And from here, this is where we need to add in our distances. We know from point B to point C, he walked a distance of 4.6 kilometers. We also know, or we will know, the distance from A to B. He walks at an average speed of 4.2 kilometers per hour, and then he walks for 45 minutes. So if we multiply the time and the speed together, we should get the distance that Adam walked. The only issue, of course, is we do have our time in minutes, which is a quick conversion before we multiply them together. So from A to B, 45 minutes is 3/4 of an hour, so 0.75. We multiply this by 4.2, and that will be our distance. Oh, I closed my calculator. All right, 7.5 times 4.2. 3.15. So this is 3.15 kilometers. All right, and then let me just erase some of this unnecessary info now. Oops. And then let me add back in the triangle. Okay, so ultimately we are trying to find the distance from the camp, which is at A, to the camp, or to the point C. And then we do have a side, an obtuse angle in between another side. So this is pretty cut and clear that we're going to use cosine law. So little c squared is equal to, let me show you the formula. cosine law. Here. And of course, C, A, and B, those are such commonly used letters that don't get confused. I'm trying to find this side, which is little c in the formula. This is angle C in the formula. And then this can be A, it doesn't really matter because A and B don't necessarily matter too much. This one is little b, and then this one is capital B, although we don't need to know that. So according to the formula, these are the variables we need. And then in terms of the question, they have different variables. But regardless, let's just follow it through. I'm going to take 3.5 squared. I'm going to add 4.6 squared. I'm going to subtract 2 times 3.15, 4.16, and cosine 101 degrees. And then of course we calculate this, and then we would take the square root to get what C, and then we calculate all of this, and then we square root it to get C. And then notice that earlier questions were in radians, and now we switch to degrees. They just hate you. So go to your mode and then switch to degrees before you start evaluating this stuff. Alright, so 3.15 squared plus 4.6 squared. Subtract 2 times 3.15 times 4.6 times cosine 101. Close this bracket, and then we do need to take this to, well, we need to square root it. And then I wrote it like this, and I'm just going to do it to the power of 1/2, which does the same thing as square rooting. So the distance from A to C is 6.05 kilometers. And then, oh, I think I need to sneeze. Excuse me. We need to find angle B to C to A for part C. And let's change colors along the way. And then I'm gonna let green be the things that I need to find. So I need to find this angle now. And I just found out that the distance from A to C is 6.05. So if you take an inventory of the things you know an angle with the opposite side. You're trying to find another angle, which we do know its corresponding measurement of side. We know its corresponding side's measurement. If this is ever a situation you're in, you can use sine law. And luckily, if you're in SL, they've gotten rid of the ambiguity, so you never have to worry about that. So if we go to our sine law, we have this. And then here's a hint. It's not in your formula book, but if you are solving for an angle, which we are in this case, this rule, we can also use the reciprocal. It might just save us a couple of steps. That's all. So I'm going to take sine angle C. I'm just going to shorten it to C. Divide this by its corresponding side, 3.15. This is equal to sine 101 over 6.05. So to find angle C, well, I guess I'll change it back to BCA. We are going to take the arcsine of sine 101 degrees divided by 6.05, and then I need to multiply it by the 3.15. Did it close my calculator again? Oh man. Okay, so let's just do that. I'm gonna double check and make sure I'm in degree, which I am. So second sine, and then inside the sine, we're gonna have sine 101 divide by 6.05 times 3.15. Press enter. So that angle is 30.7 degrees. Okay. So I'm going to go back to my diagram and I am going to add that in. I chose the lo-fi playlist, which I always do because I've been listening to lo-fi for a long time, but this is definitely more of like synthwave. But that's fine. Okay, so part D. Adam's friend wants to hike directly to the camp to meet Adam at point C. Find the bearing Jacob must take to get to point C. Okay, so let me just draw this picture down here so that I don't mess up that other one. So I'm gonna add in all of these angles again that I think I might need. And this one was 30.7. So this person, Jacob, he's at point A, and we want to find his bearing so that he walks directly, sorry, Jacob is at point A, and we want to find his bearing so that he goes directly to point C. Bearings are degrees starting from north. So if we were to find his bearing, he starts at point A, and we want to find this angle right here. Now, if you notice, that's just the angle inside the triangle plus 35 degrees. So what we're going to do is we're going to do 35, and then we're going to add angle. Leo Sam, thanks for the follow. And then I'm going to add this angle, the third angle in the triangle, which I do need to find. Can't change to blue. Oh well. I need to find this angle. Of course, that angle is 180. Subtract the other two angles. And again, this is all calculator work. $35 plus 180, subtract 101, subtract 30.7, which is 83.3. So that is the bearing 83.3. 35 plus this angle. And then Jacob hikes at an average speed of 3.9 kilometers per hour. Find to the nearest minute The time it takes for Jacob to reach point C. Okay, well, I don't even know what question this is. Question E. Some more physics for you. If you don't have acceleration, then the time is the distance divided by the velocity. This might even be in your formula book, but you should know this off the top of your head. We found the distance. That was 6.05 kilometers. They told us his velocity, 3.9 kilometers. So we just divide the two. And then just be careful and make sure that your units were matching. Because you need to make sure you're in kilometers if you're going to divide any units that involve kilometers. So take this, do the division, and notice what the question wants. It wants this to the nearest minute. It doesn't want it in hours, which is currently what our unit is in, 1.55 hours. So of course we will need to take this and multiply it by 60 to get our answer. I'm going to use the full decimal just because it's already here. And then we round to the nearest minute, so 93 minutes. And I think that was the last question, so time to move on. And then there's two more. And I'm just a little over an hour, which is pretty good time for an IB paper. You have 90 minutes to do a paper. And there's 80 questions. So as a ratio, a good guideline is, again, you have 80 questions. Well, okay, go the other way. 90 minutes divided by 80 questions means on average, you should be spending a little over a minute per question. Now, some of these marks on the side, they're pretty generous, especially these shorter ones. Like, look at this. Find the volume of the sphere, 3 minutes to do this, but it'll take you 30 seconds. Maybe a minute. You gotta look up the formula, you plug it in into your calculator. So these short ones are generally fairly generous with their timing, and I would say if you are well under 6 or well under the maximum mark for the short questions, you're pretty good, and that's pretty good. But moving on. Okay, we're measuring seashells, and then they have a normal distribution with a mean of 25, and we don't quite know the variance just yet. So we have the length of our seashells, and on average, most of them are going to be around a length of 25 millimeters. Then it tells you that the probability that x is less than 24.15 is 0.146. So at the length, seashell length of 24.15, the probability that you select a seashell under this length is that area, which is 0.1446. Okay, and then we need to find out the probability that your seashell might be in between 24.15 and 25. So they want you to find this probability. And there's no fancy functions. You do need to recognize that the area of half of the distribution, because we're going up to 25, this thing is 0.5. So if you want to find this, you just take 0.5 and then you subtract 0.1446. So that will be whatever it is. I closed my calculator again. I need to stop doing this. .5 subtract 0.01446. 3554. Hence, find the standard deviation x. So if you're ever missing the mean value or the variance and they ask you to find it, that is a strong indication that we will need to use standardized normal distribution. So what I need to do is I need to standardize this. So if this was for random variable x, standard one, here. And what I need to do is I need to change the 24.15 boundary into the standardized value. I think it's called the z value, z score. And there's a formula for that. We take the value, we subtract the mean, and we divide by the standard deviation. Now, of course, we don't know what the standard deviation is just yet, but we do have a expression for the z-score that includes the standard deviation, which is what we want to find out. There's a second way to find the z-score that's only possible with a graphic display calculator. And if we know the probability, then we can use inverse normal. So in your calculator, we go back to distributions, we go to the inverse normal. If you know what the area is, in other words, the probability, I know that probability was 0.1446. And because this is standardized, we use the mean of 0 and the standard deviation of 1. This is going to give me the z-score, which is negative 1.06. So we know that the z-score from our thing is negative 1.06. And you see, now we have this expression. We can very easily solve for the standard deviation. So let's see. Standard deviation is 24.15 minus 25 divided by negative 1.06. So let's put that in a calculator. 24.15 minus 25 divide by negative 1.06. So our standard deviation is 0.802. Okay, and then we move on to the second part. Now we gather 10 seashells. And then y is going to represent how many are greater than 26. And then we need to find out the expected value of y. Okay, so first off, if it's greater than 26, we will need to find the probability that it's greater than 26. And what's nice is we know the standard deviation now, so we can use the calculator for that again. So again, part C, first we need to find the probability that a seashell is greater than 26 millimeters. So we can go and clear this out, go back to our distribution, and then we use normal CDF. We never use PDF just because this just gives you the value, I think, whereas we want like a cumulative thing. Point is, in part of IB, you will never be using PDF, so don't even worry about it. Okay, so our lower boundary is the 26 millimeters. Your upper boundary is whatever seems reasonable to be an upper boundary, and honestly, unreasonable is probably better. So I'm going to do 10 to the power of 30, which is massive. That's 1 with 30 zeros after it. It's fine. And then I'm going to add in my mean, which was 25, and my standard deviation, which I found out earlier, 0.02. 0.802. Paste this, put it in. So 0.106. So you have a little over 10% chance of getting a seashell larger than 26 millimeters. Okay, now we can find the expected value. This is in your formula, I'm fairly sure, but if each seashell has a probability of this to be greater than 26, and you have 10 seashells, then on average, your expected value is 10 times the probability of one seashell being greater than 26 millimeters. So we just multiply these together, so you get 1.06. And you can leave it as a decimal, I'm fairly sure. But let me just double check real quick and go to the answer key. Yeah, you can leave it as a decimal because expected values, you don't necessarily need to round them to a discrete value, even though, you know, seashells are a discrete thing. Part D. But where did my music go? We want to find the probability that exactly 3 of these seashells have a length greater than 26. So this is a very classic example. They give you some sort of measurement that's normally distributed, and then partway through the question, they change it, and then now you need to consider a binomial distribution, because what we're doing is we have 10 seashells, and we're testing to see if we have 3 seashells that are greater than a certain length, and each seashell has a probability and they're independent. So this is essentially 10 trials. We want 3 seashells and each seashell has a certain probability of being whatever we desire, which is greater than 26 millimeters. So for part B, I need to zoom out more. Hopefully you guys can still sort of see this. But essentially we have n trials. I'm interested in exactly 3 seashells, and the probability of a single seashell was 0.106. So of course we just put this into binomial distribution calculator. So again, second, go to distribution, go down to binomial. And just to reiterate, We're finding a single instance where we have exactly 3, so we have a PDF, not a CDF. That's 10 trials. Probability of a single seashell is 0.106, and we are interested in 3 seashells. And here we go. So that's the probability, 0.0652. So the probability that you have 3 seashells that are greater than 26 millimeters, 0.0652. And last one. Now we have a seashell selected at random that has a length less than 26. Then we need to find the probability that is between these 2 values. So read the question carefully. They tell you that it's less than 26. In other words, in part E, you need to find the probability that your seashell is in between these 2 lengths, 24.15 and 25. And we go back to X. Ooh, low battery. And then we go back to X. And because we're measuring a single seashell, but they gave you information. So this is a given. This is a conditional. It's less than 26. So if we go to our conditional probability formula, which is right here, and we just follow it through, we have, well, the probability that a seashell is less than 26, and then the probability that it is in between these 2 values, and intersection at the same time, less than 26 millimeters. Okay, so there's a few things to unpack. One, we need to calculate this. We know the probability of it being greater than 26, so the probability of it being less than 26 is the complement. So I'm going to take 1, subtract 0.106. And then you need to think about what the heck this is. Now, think about it from a common sense perspective. If it's less than 26, then it will already be here. Or rather, if you are in this range of measurements, you are already within this range of measurements. As a full picture, I don't even know if this is going to be helpful, but these are the seashells that are less than 26. And inside of this group, there are the seashells that are in between. Specifically 24.15 and 25. So their intersection is just the probability of this itself. I don't want to write this again, so copy paste. And lucky us, we found this out way back in part like B or A, part A. So copy, paste, and then of course, whatever this is, let's just put it all into a calculator. 0.3554 divided by 1 subtract 0.016. So here's the probability, 0.398. And you're done. And then I think I have one more question. And if that's it, today's a super slow day. I think I only had like 5 people in chat at the very most, and no one's really said anything besides Ashiki Shakur, who says hello. Oh well, that's fine. Let me first double check my battery here. 20%, I can make it, that's easy. Last question. And honestly, if there's no interruptions or there's very little, then I can just take these VODs and upload them to YouTube. Because I read that what brings in traffic to Twitch channels is actually YouTube because of their algorithm, and not necessarily just Twitch streaming a lot on Twitch. Like, that will get me affiliate eventually, but to get viewers in, apparently they get redirected from YouTube quite a bit. Okay, let's see. We have a function. It is, I think that's supposed to be a decimal, but this might be from time zone 2 across the pond. So 5.8 times sine, blah, 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 blah. And then we have a specific domain, 0 to 10. B is all real numbers. Then we need to find the period of f. So there's a few parameters here. There's A, there's B, there's C, and then, well, this is a little confusing, but traditionally I call this one D. But the question calls it B. But that's fine. To find the period, this is typically sine. Sine has a period of 2 pi. We have a, I think, horizontal expansion. Well, we have some sort of horizontal stretch by this value of b, pi over 6. So we take our default period, which is 2 pi, and then we transform it by dividing it by pi over 6. The pi's cancel. So my period is 2 times 6, which is 12. Then the function has this maximum here, and it has this minimum here. Then we need to locate the value of the questions b. You know what? Let me change these to uppercase so that this might be less confusing to you guys. Okay, so visualize this, right? We have a maximum at 2 and 21, so somewhere over here. We have a minimum at 10.2, somewhere over here. Now, this function transformation d, which is the questions b, is a vertical translation. So sine normally has a center at a y value of 0. But what you did is you moved it up to here, in between the middle of the maximum and the minimum. So this is my b value. So let's just find the middle value. You just add the upper and lower boundaries and divide this by 2. Divide by 2. Oh, it adds to 32. That's nice of them. So 16. So now I know that this is 16. So hence the value of b is 16. And now that we know what b is, we can plug in any values of x we want and evaluate. So I need to plug in an x value of 6. So exciting. Oh my god, I closed my calculator again. Alright. So punch it all in. 5.8 times sine pi divided by 6 times x. Oh, well, x is 6 now, so let's change that to 6. Plus 1, close, close, and then plus b, which we found out is 16, so plus 16. And so my value of f of 6 is 16.4. Alright, and then let's see. A function g is given by this other sine equation. And then the function passes through these points. Hence, we need to find the value of p and q. Okay. A pretty typical setup, not necessarily about the sign, but we have two unknown values. We have p, we have q. They tell you two pieces of information. The graph goes through this point and this point. And that's a pretty typical setup to solve a system of equations. Basically, I'm going to plug in these x values, and then this will give you the value of g. And then I'll have two equations in terms of p and q. And then you can do whatever you want to try to solve them. So let me just do that right now. First off, I'm going to plug in 3 and 2.5 into my function. So 2.5 is going to equal p times sine let me try to make this look a little more appealing. 2 pi over 9. And then my x value is now 3. So 3 minus 3.75 plus q. And then we do the exact same thing. Actually, let's evaluate all of this first, because this is going to simplify all into a decimal in our calculator. So sine. I might have done this wrong. I'm a little worried. Hold on. This question is in radians. So I need to redo this one, find f of 6. Everything else is fine so far, but I do need to redo that one. So goodbye, 16.4. Can I go back and edit this one? Yes. So because I just copied it and then the calculator pasted it for me, and then I think if I just press enter, well, okay. I need to delete everything first. You know what? Forget it. We're starting from the beginning. 5.8 sine pi divided by 6. 6 plus 1. Bracket. Might need another bracket. And plus b, which was 16. 13.1. Save myself a little bit of error here. 13.1. Okay, and then back to this one. Let's make this, all of this look nice, at least as nice as it can be. Sine 2 pi divided by 9 bracket 3 minus 3.75 bracket negative 0.5. Wow. So this is going to be negative 0.5 p plus q. And then we do the exact same thing. We plug in the second point to get a second equation. So I plug in 6 now. And same thing. We are going to try to find out what this is as a decimal. Sine 2 pi divided by 9 bracket 6 minus 3.75 which is 1. Wow, they really designed these nicely. So this just becomes p plus q. Okay, there are tons of ways to solve for p and q as a system. And then now that we also have the fact that we have a calculator, we have even more ways to solve it. What I'm going to do is I'm going to put these as graphs and then find their intersection. Just be very careful what you assign as the x value and the y value. So just pay attention. But if you follow the format, it shouldn't be that hard. Clear? So I'm going to do this graph, which is... Oh, well, if you pay attention, these need to be in terms of one variable. So what I'm going to do is I'm going to move this p term over. So I'll have the equation positive 0.5p plus 2.5, and then this one here will be q equals negative p plus 15.1. And then you can see that q will be the y value of the intersection, p will be the x value of the intersection. So 0.5x plus 2.5, and then down here we have negative x plus 15.1. Office Nike, thanks. Okay, so graph these. Oh shoot, I didn't fix my window. Okay, it's somewhere over here. So I'm gonna change my window, and I'm gonna change that to 10. And then I don't think I needed negative 20. So let's see. So there it is. All right, and then we can second calculate the intersection of two graphs. So enter, and then move to your guess. So there's the intersection, 8.4, 6.7. And then you do remember which variable you assigned for y and p. Q was the y value. Q is 6.7. P was the x value. .4. And then we need to find the value of x for which these functions have the greatest difference. In other words, the most efficient way to do this, at least in my opinion, is, well, you find their greatest difference. In other words, we need to subtract them. So this itself is a new function. I'll call it, you know what? Yeah, I'm just gonna call it h. So h measures the difference, and we want to find the greatest one. So we essentially optimize this, but without calculus. So I guess I shouldn't say optimize. We can find the greatest value using graphing functions. All right, so here we go. Time to type this all in. Clear this out, clear this out. And then I'm gonna put f minus g, so 5.8 sine pi divided by 6 bracket x plus 1 bracket, another bracket, plus 16. And then I'm going to subtract the g function, which was all of this stuff. And then we did find p and q. So it's p, which was 8.4. 8. I'm running out of so much room. 8.4. Sine, and then it was 2 times pi divided by 9, bracket x, subtract 3.75, bracket bracket. Do I need another third bracket? I don't think so. And we finish off with plus q, which we found out was 6.7. Plus 6.7. All right, and then we go to the window, and then let's pay attention to some things. What should my window be? Their domains are between 0 and 10. So your window should be between, I'm going to give it a little bit of leeway from -1 to 11. And you don't have to do this part, but I will, just so that I can see the graph clearer. For the first function f, the values are in between 21 and 10. And then part g, function g, is in between 2.5 and 15. So I'm going to take a risk and have my minimum be at not quite 0, but -1. And I'm going to have my, oh yeah, okay, let me leave. My minimum will be at -1, and my y minimum will be at -1, but I should up this maximum. I'm going to change it to 30 just in case. Oh man, it does dip below. Okay. So let me change the window a little bit more. Not that I will need to, but I do want to point out a few things. Let's do 10. Okay. This is f, all the values of f minus g. And we want to find the greatest difference. Now, you do have to be very careful about what that means. It might not necessarily be the largest value you see in terms of like positive. It is in this case because essentially f minus g at whatever this value is, I think that's like a little over 1. The absolute value of f minus g, this is larger than the difference here. So if you did have a hypothetical graph where the difference was like this, this is the greatest difference. It's negative, but that's fine. We're looking at the absolute value. But regardless, no need for calculus because we can calculate this using our functions. Second calc, maximum. And then we go to the left. And then select, go to the right. We select. Select a guess. So our maximum, which is where our greatest difference is at the x value 1.64. So by your graphing display calculator, that x value is at 1.64. And then I forgot to mention, but when you do stuff by graphing calculator, that's significant, not just like regular calculator stuff, but like you're using functions, you're graphing, you're using graphing functions. You should probably say that you used it, just in case they might dock you marks. Now obviously you don't need to say that you used the calculator to add two numbers together that you couldn't do in your head. But for any major things, you should probably tell them, hey, I use the graphing calculator here. I know what I'm doing. So give me all the marks. I'm not just guessing 1.64 willy-nilly, and I somehow got it right. And then I think I'm done. And given the time, which is like an hour and 40 minutes, which is 100 minutes. So I'm 10 minutes over time, but of course I went through this very slowly. I explained things. And I was clicking around, you know, searching up the volume of a sphere and whatnot. But let's just see, before I close off, how much I got right. So here, close this, and then not this one, this one. Will I get 100%? I don't know. Honestly though, I'm gonna get a 7. I know that for sure. This is SL, and I can get a 7 with my eyes closed for this stuff. But it might not be right. Hold on. Jeez, I thought this was a PlayStation login. You know the PlayStation login sound? Excuse me. Alright. Find the volume and answer in the form A times 10 to the power something. Oh man, can you guys even see this? And make sure that A is in between 1 to 10, K is an integer. Oh, whoops. The answer is 8.58, and then I forgot to do 3 sig figs, so didn't get 100% already. That's fine. I misread the question, and I thought when it said K as an integer, I thought it meant A. So then I rounded it to the nearest integer. Oh well, that's fine. Part B. I did not do right because what did I do? Oh, I found the height, and then I was supposed to find the radius, so I completely plugged this into the wrong thing. Ah well, whatever. It's only 3 marks. I can afford 3 marks. Moving on. 1.35, 1.35, 16.3 centimeters squared. And then 35. Oh, why did I get this one wrong? What am I missing? Pi r squared for the area of a circle. And then half pi okay, my math is right, so I must have put this into the calculator wrong, because this is exactly equivalent to this. Oh well, calculator mistake. I only lose 1 mark for that, if that's the case. Okay, find the R, 1.056. Why is this in 4 sig figs? Whatever, this is equivalent. And then solve for P, blah blah blah, 2032, 2033. Oh, okay. So remember how I said I rounded up? She will get it during 2022, just 0.6 of the year in. So I guess technically, if you really wanted to talk about what year she's gonna get it, she would get it in 2032 and not in the year 2033. Oh well, math is fine. And then let's see, 0.472, 0.472, 0.0185, 0.0185, nice. A and B are the same. P and Q are the same. Maximum distance, 16.5 centimeters, we have that. Second derivative, negative 9.8, negative 8.92, negative 8.92. We have 3.15. 101, we just showed that pretty easily. 101. 605 kilometers. 605 kilometers. Or sorry, 6.05 kilometers. Sine rule, 30.7. And then right there, 30.7. And then 48.2 whatever. Oh, which is right here. I included it in the math. We didn't need to find that. We needed to find the bearing, which is 83.3, which I have right here. And then, let's see, 93 minutes. 93 minutes. Okay, and then probability stuff. 3.554, 3.554, that's good. Use the inverse. Our standard deviation is 0.82. I have 0.802. Yeah, same thing. Probability of greater than 26 right here, so that's good. Expected value 1.06. I checked that earlier. 1.06. Probability of y being 0.0655. I have 0.0652, so there's a little bit of rounding error somewhere. Whatever, that's good. Recognizing conditional probability and plugging it in to get 0.398, which I have right here. Nice. And then this was the last one. Period is 12. Little b is 16. And then luckily I caught myself here because I was in degree mode, but you should be in radians. 13.1, I have 13.1. Solve for P and Q, which is right here, 6.7, 8.4, 8.4, 6.7, and then the greatest value is, again, the absolute value of their difference, which was 1.64, which I have 1.64. So overall, all of my math is correct, except for solving for R for the very first question because I solved for H. But honestly, I maybe lost like 4 marks total. And if you've seen the grade boundaries, to get a 7 on a paper, pretty generous. I think the lower bound is like, at the time, this one is the grade boundaries from 2019. So this was paper 2, 70%. And I only lost 4 marks out of 4 to 5 marks out of 80. Let's be a little mean and say that I lost 5 marks. So like my score is 75 out of 80. And I have 90 something percent, good enough. So there we go. Wait, marks are out of 90. Oh, and this is different. Oh, this is the old curriculum. But, so I think the old curriculum was out of 90 marks. Point is, I'm really close to the upper boundary of a 7. Not bad, considering how much I hate calculator stuff. Anyways, I think I'm gonna call it. It's been a slow night. It has been about 2 hours. For those of you who have joined, thanks for watching. And yeah, I'll probably stream again Sunday. Last time I did though, I did it in the afternoon, which was the change in the schedule so far, and that was also very slow. So I don't know if it's just slow because the hype has died down. It probably is true. So maybe it doesn't even matter what time I stream on Sunday. I don't know. We'll see. I'm probably gonna try 2 o'clock again, and then we'll just go from there. Alright guys, thanks for watching. I'll see you all later. Hey, do you think exams will cancel? have you been browsing the Reddit? I don't browse the Reddit too much, but I know there's a big hubbub about whether or not the exams will be canceled. 24/7? Yeah, and I've heard it's like an all-out war down in that subreddit now. My personal opinion, I'm on that Reddit. Is that how you found me? Or are you one of my students? Personally, I wouldn't count on it. They canceled last year, and that was a shit show. It was obviously rushed, and then you know what they decided to do? They decided that I'm pretty sure 100% of your grade was based off of your IA last year, which is ridiculous. I didn't teach the graduating class last year, but there were some students that if they wrote the papers, they would have gotten a final grade of like 2. But their IAs were so well written that they walked away with like a 6. It was so bad. I heard rumors though, and again, don't quote me on this because like the upper echelons of IB don't communicate to lowly teachers, but if they were to cancel it, then they would try to balance your mark, your final grade, between your IA mark and your predicted grades by your teachers. Either way, it's not a good look. I'm in the same boat. If I do exams, I'm getting a 3s, but if I don't, and they count my IAs, I'm getting like a 5 or 6. Well, I'm glad that you found me then. Are you an SL or HL, by the way, Magic? AI SL, oh shoot. I think I can help you with most of AI stuff. I don't teach AI, my school only offers AA, but honestly, I feel like I could just wing it. So if you do need help anytime that I'm streaming, then pop in. And maybe if we do have exams, because you actually follow me, maybe you won't get a 3 if you write those exams. No guarantees though. You get what you pay for, and I'm free. But yeah, who knows, honestly. It depends on so many factors, right? All the old farts at IB, whether or not they think the papers are worth it. Depends on how bad COVID is around the world by that point, how many vaccinations there are. Is the world going to catch on fire because the States is going to explode any minute now? Or the world is going to explode any minute now? Who knows? But I would not count on it. And I would not rely on the hope that the papers will get canceled, because that would be really, really bad. So just treat it like normal, study, etc., etc. You have class in 10 minutes. Okay, thanks for watching, Magic, and I'm actually signing off anyway, so see you guys later. Bye.